Hi, my name is DIVESH MAKENDREN. So before I start this meeting, can all of you introduce yourself?
Okay, my name is SYAFINA binti JUMRI and my metric number is 205753 and I am one of the presenter for this project proposal.
Hi, my name is Muhammad HAZIM bin ABDUL RAHMAN and I am the second presenter for this project proposal.
Okay, hi, my name is AIMAN FARISH bin KAMISAN and my matrix number is 208224 and I will be the last presenter.
Okay, so without further ado, let's start our meeting. Okay, so basically, I am a tender for electrical irons. Recently, a company approached me to tender and asked for certain modifications that could be done. I have noticed that based on my previous clients, there were many problems faced by them, mainly the thermostat in the iron, which leads to overheating of the iron. So do you guys have any ideas or suggestions on how to improve the performance of this iron so that it saves more energy and it is easy to use?
Okay, before we further our presentation, first of all, let me explain about the thermal stress. Okay, thermal stress is actually a mechanical stress caused by a change in the temperature of a material. So when a material is rapidly heated or cooled, there will be a temperature differential between the surface and the inside of the temperature. So generally, this is the introduction of the thermal stress that happen in the thermostat. Okay, next I'm going to explain about the description of the thermostat, which is in the electrical iron. So basically, we understand that thermostat is a component of a regulating device that detects the temperature of a physical system and takes steps to keep the temperature of the iron near a set point. So basically, in the iron, we use the bimetallic strip, iron. We also can use steel and brass. So basically, these two type material is very available for the thermostat of the iron. So next, here are the photos of the thermostat in the iron. So in this case, this is the thermostat of a keen electrical iron. So next, I'm going to pass to next presenter.
Okay, thank you, Syafina. Now I will explain about the problem that we have to improve in our iron. Okay, first, iron is an electrical iron uses a fundamental mix of heat and pressure. The heating element, on the other hand, becomes hotter and hotter if the iron continues to receive electricity from the power source. This wastes a lot of energy since an iron burns a lot of power in only a few minutes, damaging garments and, in the worst case situation, creating significant and perhaps catastrophic mishap. That's why we use a bimetallic strip in the iron thermostat. A bimetallic strip is made up of two different types of metals that are linked together and have different coefficient of expansion. As a result, the bimetallic strips expand differently in the presence of heat. Bimetallic strips can be utilized as thermometers or as thermally dependent mechanical parts like circuit breakers in the iron. So we have to optimize the specific engineering use and ensure that the element attributes remain within predicted range under nominal condition, which is especially important in safety critical application. In this proposal, we want to suggest on how to improve the bimetallic strip in the iron. Mr. Hazim will explain further about the details. Thank you.
Okay, thank you. So now, Mr. Divesh, here are some improvements that we suggest to improve the thermostat in your future product. As mentioned in the problem statement previously, accurately predicting the thermomechanical response of these bimetallic strip architectures is critical for engineering, design and application of electrical iron. There are some modifications that could be made in order to enhance the functions of the appliance. The most crucial part to be modified in the electrical iron is the mounting or the joinability. The inactive lengths of bimetal elements should be clearly defined as closely maintained by rigidly mounting them to their support. Another important design consideration is mounting or the installation to avoid overstressing. Depending on the requirements, attachment can be accomplished by riveting, bolting, spot welding, soldering, or brazing. Materials with outer layers have been developed to meet the joining requirements of specific industries. Brazeability is improved by using an outside copper layer. To meet specific welding requirements, thermostatic bimetals can also be plated with materials such as nickel. Another aspect to be considered is the corrosion. When mounting thermostatic bimetal parts to other metallic parts, extra caution should be taken to ensure that no galvanic action occurs, which could result in bimetal corrosion over time. Thermostatic bimetal strip on parts may be electroless or electroplated with silver, nickel, tin, cadmium, zinc, or gold to improve service life. The physical properties of thermal deflection and thermal or mechanical force are often unaffected by plating. High manganese content of the high expansion alloy in the thermostatic bimetals are highly susceptible to corrosion and stress corrosion cracking. As a result, they should be avoided when exposed to high humidity, moisture, or saline solutions for an extended period of time. Last but not least is the adjustment or the calibration to compensate for normal production tolerances on parts and to ensure accurate performance. A means of adjusting the thermostatic bimetal element should be included in the design. It may be more cost effective to provide for mechanical adjustment rather than specifying tight tolerances on the part itself. The means of adjustment should not affect the element's active length and should ideally be located on a component member of the assembly. Friction must be assessed and its effect accounted for as an extra force requirement in the design. So that's all from us.
So, thank you so much for the presentation from Mr. Hazim, Mr. Farish, and Ms. Shafina. So I clearly understand on your ideas on how to modify this iron. So based on this presentation, I understand that this modification can help to improve the performance of the thermostat in the iron so that it will make a better use for the consumers of this world. So thank you so much.
Thank you, Ms. Divesh.
Thank you, Mr.
Divesh.
Divesh.